Hey guys, welcome to episode 1 of Oddly Specific Godot Tutorials, a tutorial series where I got bored and decided to make something really weird that no one actually needs to know how to make. Today, we're making a helicopter. First thing you want to do is make a new game project. I keep all of mine in a folder on my desktop because I'm a weirdo. Right, so once you've loaded into Godot, you want to create a new scene with a rigid body as the base. Name it helicopter because it's going to be a helicopter. Add a mesh as a child of the helicopter and give it a new cube shape. I'm going to go ahead and add a new mesh instance as a child of this one and call it Propeller. This one. I'm going with this one. New cube shape. Drag it up. A little bit more than that. And there we go. That's a helicopter. You know what he needs? He needs a smiley face. Right, anyway, actually making the tutorial. Click on the main mesh instance and create single convex collision sibling. This will give our rigid body the same shape as the mesh by adding this collision shape here as a child of the rigid body. Also, helicopters are supposed to have tails, aren't they? He has a very squarular forehead. It's probably because he's a cube. Does he need nostrils? Nah, I like him better without it. That does give me an idea, though. We should give him, like, more eyes. So, I made this abomination of a thing. Add a script to the helicopter. And this is where we're going to be controlling the custom physics. Now, most of the physics can be handled by the game engine. It's a rigid body, so it already, falls and bounces, collides like a normal physics object would. What we need to do with this script is apply upward force and torque force to make it fly around like an actual helicopter. I'm actually going to take a minute here to explain the control scheme that we will be using. Here's the helicopter. If you're wondering why this is so low resolution, it's because I'm drawing this in a pixel art software. Right, so here's the helicopter. We need to be able to have it rotate this way and this way. We also need to have a control that can apply more or less upward force. When you're not touching the controls, we want it to apply exactly enough force for the helicopter to float in place on one level. And also we need to have the helicopter, it's a little hard to draw, isn't it, turn on this axis. So we're going to use the mouse for this section. The mouse will control all of the rotation around this axis. That way, if you wanted to aim, you could aim like you would in a normal first-person shooter, moving the mouse side to side to rotate the helicopter side to side, and up and down to rotate it up and down. Now, we also need to have a way for it to rotate around this axis in both directions, and we're going to be using A and D for that. W will accelerate it upward, and S will bring it back down. So, because we're using mouse controls, the first thing we need to do is add a ready function, and on ready, input.set mouse mode captured. By the way, right here, I'm updating my physics FPS to 144 to match my monitor. because if you don't, it's a little bit jittery. So if you have a monitor that doesn't do 60 FPS, you're going to want to change this. It's in project settings, and then general, physics, common. After that, we add func physics process. This is called every single frame. We need to add a variable called throttle and set it to 1. This is going to be our multiplier for the amount of upward force that is applied. And so if you press W, we want to turn this to, say, 1.7, and if you press S, then we'll want to turn it down to 0.3. We're going to need to add these key bindings manually, so go up to Project, Project Settings, and Input Map. W, A, S, and D. And then go to the little plus icon right here, add a key, and add each letter for that letter. Now we can reference these through our code to get booleans based on whether or not they're pressed down. So in physics process, write if input.is action pressed. So on every single frame, if the W key is down, we want to increase throttle to 1.7. And if input, got to capitalize it, is action pressed S, then we want to set throttle to 0.3. And actually, just so that we can make sure no other keys are pressed, we change this to elif. So if W is pressed, it's going to do this, but if W isn't pressed, it'll check for S. That way we can put else here. Else is only called if W and S are both not pressed, and in that situation we want to set throttle to 1. Now we need to use that throttle function to actually apply forces to the physics object. So in the rigid body class, there's a function called add central force. And we are going to say vector3 dot up. This code will apply exactly 1 upward force every single frame. But the physics engine, because its weight is 9.8, is already applying 9.8 force down every single frame. So to counteract this, we're going to say vector3 up times weight. The upward force will always be exactly enough to counteract gravity. Now, we want to add throttle to this function so that the player has control over how much upward force is applied. So, if we run this code, so we forgot to add a camera. Yeah, that's important. It lets you see what's going on. Alright, drag the camera, click preview to make sure that looks okay. Oh, yeah, the camera still isn't very helpful because we don't have anything to reference it against. If we hit play now, it'll just look like, you know, this. So we're going to make a new scene, 3D scene, call it world. I'm going to add a new child to the world node, a mesh instance. The only point of this is to have like a frame of reference, so we know like what direction the helicopter's traveling in. Because the helicopter by itself, we can't learn anything since the camera's attached to it. Also, planes are only rendered from one side, so I'm going to switch this to a cube. Right. And then we want to add click on the little chain icon to instance a child scene and add the helicopter. So now you want to set world scene, set as main. That way when it runs, you can see that W and S are applying force to the helicopter just like we would want them to. However, there is a slight problem. If you don't touch anything, it drifts upward. And we want, if you release the controls, you to hover in one place. It does stop eventually, but it's very slow. So go back to the helicopter scene, go to the helicopter rigid body, and increase the angular damping to about 1. Right, and angular damping, go ahead and set that to 1, even though we don't have any rotation set up yet. Next thing we want to do is set up rotation. The only way, well, I don't know if it's the only way. The way I use to get mouse movement, actually, you can't do it in physics process. You have to call a separate function, a built-in function called func input event. Say if event is input event mouse motion. So what we're going to have to do is get mouse motion in this function and then pass it back up into this function as a global variable. So go ahead and declare one in here, call it mouse movement equals vector 2. So if event is input mouse motion, so if the event we received is the mouse moving around, then we can call event.relative. Event.relative is only applicable to this kind of input event, and it is the vector 2 containing the coordinate change from mouse position last round to mouse position this round. How far the mouse was moved with an X and a Y. So we're going to set mouse movement. Actually, don't set it. We're going to add event.relative to mouse movement. Back up in physics process, we're going to say if mouse movement does not equal 0, actually, vector 2 dot 0. So if the mouse moved at all, we want to add torque. Add torque is a lot like the add central force function. We are able to pass a vector 3 and it will rotate, it'll apply a rotational force around the axis that we pass. We want to apply torque vector 3 dot down times mouse movement dot x. So the amount that the mouse moved along the x-axis is going to be multiplied by this vector. So that will tell us how fast we need to rotate, and this is the direction we need to rotate around. Go ahead and copy and paste that. For the second one, we're going to rotate around left by mouse movement dot y. And actually, these values are way too much. So go ahead and divide both of them by 70. And let's try it. So it's chaos. It's utter chaos. I forgot a lot of things. Next, we're going to set mouse movement back to 0 because it's been used. This adds to mouse movement. So if somehow input event gets called twice before a physics process frame, then it'll add both of those mouse movements together by adding event.relative twice, and then here it uses both of those mouse movements to rotate the physics body, and then sets mouse movement back to vector 2 dot 0. Actually, you don't have to put dot 0, you can just put vector 2, and it assumes everything's 0. Now, if you run the game, it, wow, divided by 70 is a lot. Divided by 7. Yeah, so this works decently. There is one major problem. These vectors are in the global space, so it doesn't matter if the helicopter is upside down, the torque will still be applied in the same direction. So what we need to do is transform all of these vectors to be in the rigid body's local coordinate system. And we can do this using global transform, which gets the global transform of the rigid body, global transform.basis, which gets a very complicated array of numbers that define its rotation in 3D space, and then dot xform. Xform, you can pass a vector 3 through the xform function, and it will set the vector 3 to the local coordinate space of the basis. So just apply this function to all, and apply it to add central force too. Now it should be working properly. Yeah. Alright, next we need to set it up to rotate around the z-axis. When we press A and D, if input dot is action pressed A, then we want to add torque, global transform basis dot xform, say vector 3 forward. Copy and paste this. So this is rotating around the forward axis, which means that it's leaning side to side. Pass back through here. I'm not actually sure if these are right. We might have to switch those. Yup. Alright. So set this to A and this to D. D correlates to forward. A correlates to back. And it actually seems like the strength of this rotation is just about where we want it. I would like a little bit more rotation from these guys. So I spent a little bit tweaking the movement. It feels a lot better now. These are the numbers I came up with. 1.5, 0.5, and 1 for the throttle. Divide the mouse movement rotations by 3 and multiply the key press rotations by 3. And you'll get a pretty smooth movement of the helicopter. I actually got this control scheme from Ravenfield Beta 5. The flight controls in Ravenfield Beta 5 are some of my favorite in any game. Because of the fact that the mouse moves the camera, you can directly move the mouse around to aim at things, which makes dogfighting a whole lot easier. One thing I would like to add is at the bottom of the physics process function, just say $. We can use this to get nodes that are children of the scripted object. We are going to get the propeller dot rotate around the up axis and angle. I believe this is in radians, so we're gonna have to make it pretty small, especially since it's running every single frame. Yeah, that worked first try. Huh. Alright then. Another thing that bugs me a little about our current version is that the camera is attached to the helicopter, so any movement of the helicopter doesn't show up on camera at all besides changes in lighting, which looks a little weird. So the way we're going to fix this, add a new spatial node as a child of the helicopter. It's just a empty 3D position, and rename it camera pivot. I can spell. add the camera as a child of the camera pivot. So the camera pivot is at this position, and this allows us to rotate the camera smoothly, because if we rotate the camera pivot, you can see the camera rotates around the helicopter, whereas if we had just rotated the camera, it would look like this. Yeah, not good. So come down here, and what we want to do is we want the camera to lag a little bit behind where the helicopter is moving. So we can get this using the angular velocity, which is stored as a variable. Let's say camera pivot dot rotation equals negative angular velocity. So what this does is it gets the rotational speed of the helicopter, and negative moves us backward along the direction that the helicopter is rotating. So the camera will be pushed behind where the helicopter is. So it doesn't actually lag behind, but it gives that illusion just by, oh, okay, that's that's a little strong. Divided by 40? So yeah, it moves around ever so slightly. It just makes it feel a little more natural, less static. I think we can turn it up a little. Yeah, it is a little bit disorienting. There's probably a better way to do it. But this is definitely the simplest way. And I don't feel like doing hard things. So, by this point, you should have a fully functioning spider helicopter. It'll just be a helicopter, but that's okay too. We can make this a prettier color. It's a terrible color. Gray? I don't know. What should it be? What goes well? Let me just... Okay, so this is the color we use for the rest of the helicopter. If we just invert all of these values, that should be a color that goes along well with it, right? That's like the opposite side of the color wheel. But I thought orange and blue were across from each other. It's half of 255. Does this do math for you? It does. Alright, yeah, that's what color we're going to make the propeller. I'm actually going to speed up the rotation of the propellers a little bit, just to make it look a little, yeah, that's actually pretty good. So I'll add this scene as a downloadable, I'll add this island scene as a downloadable underneath the video somehow. I'll figure that out. But this is just a huge static body area. You can fly through the clouds, you can fly through the water. It's just a little scene I set up. And if you set it as the main scene, then click on Island, click on the root node of the scene, click on the little link, and add your helicopter to it. Move it up so it's not in the ground, and then hit play. You should be able to fly around inside the scene. So yeah, I guess that's the end of this tutorial. Like if you liked, dislike if you disliked. Actually don't. If you disliked, just leave. Disliking is... I've never disliked a video. I don't understand people who dislike videos. That doesn't make any sense. Like, just leave. Like, it's just as easy for you to leave. Why do you have to harm the person because you didn't enjoy? Anyway, I got sidetracked. Bye.